This is a video which covers the initial part of isomerism, the AS, CCEA, although it's probably applicable to many specifications. Isomerism section, so we're going to look at structural isomerism. Within that particularly we're going to look at chain isomerism, and we're going to look at positional isomerism. This video won't cover EZ isomerism, won't cover cis-trans isomerism. That will be covered and is covered elsewhere. So let's look at the first things we're going to do. So first of all, we're going to have a look at defining what these different types of isomerism is. We're going to recognize and do some tasks on being able to recognize and draw those different types of isomerism. So let's start back at the start. We need to understand first of all what empirical formula is, and we should all know that by now. Empirical formula is of course the simplest ratio of atoms that you find within 1 mole of a compound. So you may take that from a percentage by mass, or you might just take it by an amount of mass of each of the elements. You convert those into moles, and then you convert those into the simplest whole number ratio of atoms within a compound. So for example here we've said we've got an empirical formula of a compound, 1 carbon to 2 hydrogens to 1 chlorine. We can convert that then into a molecular formula, and a molecular formula is the actual number of atoms within a molecule. And the way that we can convert that from empirical to molecular is that we must know the RFM. So if we look at this here, we can see that the RFM is actually half of the 99. Okay, so it's 49.5. If we added that all up, we know that 99 is double that. So therefore, the relationship between molecular formula and empirical formula is 1 to 2. So we just double everything that is in the empirical formula to get the formula of one molecule, keeping of course the ratios at 1 to 2 to 1. I probably should add here that a lot of people get mixed up with a molecular formula and, for example, a condensed structural formula. A molecular formula level is just the number of carbons, number of hydrogens, number of, in this case, chlorines, and they're just listed in that order. If you give the wrong formula for an answer, for example, what is the molecular formula of this? Okay, let's say you drew out a structural formula, or maybe did something like this, okay, or maybe you did something like this, okay, you would be dicing a little bit with losing your marks in that instance, I'm afraid. Okay, so just be careful, know the differences between your formulas. Some people do, some people don't, and it's a very easy way to gain marks, but also a very easy way to lose marks. Right, if we then look at this molecular formula that we have managed to calculate for ourselves, we can then convert that into a structural formula. But if we know a little bit about naming and drawing organic molecules, which we should do at this stage, we will notice that we can have 2 possible different structural formulas from the molecular formula listed on the board. On the left we have what we would call 1,2-dichloroethane. On the right we would have 1,1-dichloroethane, and the only way that I can turn one of those into another is by breaking bonds, so therefore they are different molecules, and we have to appreciate that in chemistry. Now the relationship of those two together are isomers. So these two things which have different structural formulas but the same molecular formula, those are what isomers are, and that is one of your definitions that you would have to know for your exam. It's one that's commonly asked also. So provided the 2 things adhere to that definition, they are considered to be isomers, okay, or structural isomers I should say, in this particular instance. Right, let's move on. So we already know about the nomenclature, we know about naming organic compounds, we should know quite a bit about it. And we should know that molecular formulas, we can turn them into unique names. And we follow for that what we call IUPAC systematic naming process. IUPAC stands for International Union of Pure and Applied Chemistry. And basically, in a nutshell, they're the people who tell us what sequence of rules to follow whenever we are naming not only organic molecules but many other molecules. And the process is called nomenclature, or nomenclature rules, if you hear that. Okay, so you may be asked an exam for the IUPAC name, or you may be asked for the systematic name. And the systematic name just means follow the system of rules given by IUPAC to generate a name. So please make sure that you are familiar with those. I'm just going to very quickly revise over some stuff that we should have already done. So when we're doing this, when we're naming anything, we look for the number of carbons bonded in a continuous chain, and that's really important, the term continuous chain. So for example, if I had something like very, very simple, that my continuous chain is 4 carbons. This carbon here is not in my continuous chain. So we're always looking for the continuous chain. We then look for the presence of particular groups or atoms bonded to that carbon. They are functional groups, or in this case that's a methyl group, which is called an alkyl group. Okay, we've already met these. Okay, and then we look for the position of those particular functional groups or alkyl groups within them. And we generate a name based on all of those 3 criteria, and we give it the molecular formula, its unique name. Okay, just a very quick reminder of the prefixes that we use for the various different lengths of the carbon chains. And again, we should know these all and know them well by this stage. Right, sorry, that's just a repeat of the slide that we had previously. So let's look at isomers now at A-level or at AS level chemistry. Okay, you have to know about structural isomers. Those are the isomers that I've already spoken about, and you also have to know about stereoisomers. Stereoisomers are EZ isomerism and cis trans, and they're covered in another video. Okay, so we're going to dedicate this video to looking at structural isomerism. Structural isomerism, again, I'll remind you of the definition: molecules with the same molecular formula but a different bonding pattern of those atoms, or in other words, a different structural formula. Stereoisomers are a little bit different in that they're isomers resulting from different spatial arrangements of the same atoms in the same structural and molecular formula, in fact. So they're a little bit more challenging, but not particularly challenging for anybody doing A-level chemistry. Right, let's look at structural isomers. And as often the way in chemistry, we lead you down the isomer path here. We talk about structural isomers, and then we tell you that in actual fact, within structural isomers, there's 3 different types of isomers. We have chain isomerism, which we're going to do first. We have positional isomerism, which we're also going to do. It's very simple. And we have functional group isomerism, which we're not going to do because it doesn't apply to AS chemistry. It comes in whenever we get to A2. We may have a wee look at it if I've got time at the end of this video. But primarily, we're going to look at the chain, okay, which is the one that I've spoken about, okay, already, and positional, which is also the one I've spoken about already because I've spoken about structural isomers. Okay, functional group we will get to. So chain isomerism is just very simply isomers caused by different arrangements of the carbon atoms to form straight or branched chains. We should have met, or you should have met, straight and branched chain alkanes already. Now it doesn't just apply to alkanes, but it does apply to carbon chains. Positional isomerism is the simplest of the lot. Isomers caused by changing the position of the same functional group. Now, we'll do some worked examples, and I think whenever we do the examples, things will become an awful lot clearer. So these are chain isomers, and I'll just remind you of the definition there again. Isomers caused by different arrangement of carbon atoms to form straight and branched chains. So let's say, for example, so these are split into 2 separate sections above the red line and below it. So let's say the examiner said to you, he wants you to draw all of the chain isomers for C4H10. So in other words, they are allowed to be branched, they're allowed to be straight chain, but they must be C4H10. They must have the same, remember, this is the molecular formula, they must have the same molecular formula, but they must have a different, I'll just write SF, structural formula. So if we look at C4H10 for these chain isomers, there is only 2 possible chain isomers of C4H10. Obviously, I've picked a very, very simple one to get us started here. Now, but we will come across more challenging ones, and we need to know what process to follow in order to work out which isomers there are, how many there are, and make sure that we don't, most importantly, don't duplicate one with another. Right, so very simple. If I was asked, and I think any student would probably do the same, if I was asked about C4H10, the first thing that I would probably do is draw out straight chain, linear chain of C4H10, and that counts as one of the isomers. Okay, and we would be asked to name it, and that is of course bute for 4, N for all single bonds, and the E at the end telling me that it's this hydrocarbon, an alkane. Right, how do I then work out what the next one is? Right, here's the very simple rule that you can follow for A level and it will work. I've never known it not to work, put it like that. You take one of the carbons off the end. Now that could be either the one on the right that I've put in a red box, alternatively it could be the one on the left, doesn't matter. You then put that carbon on any carbon that is not on the end. For example, I cannot put it on this because this, once I take this red carbon in the box off, that carbon with the X on it is at the end. If I look at the other one, I can't put it there because that's also a carbon that's at the end. In other words, my only option now, if I have my 3 carbons, okay, my own with my X and X from over on the left hand side, my only option is to put my CH3 there. Okay, now that gives me this time methyl propane. Okay, we don't need the 2 because the methyl can only be by default on the middle carbon, so I don't need to write 2-methyl propane. Okay, now I'm then probably going to ask myself, well, is that all the options? Are there any more? Can I put this carbon anywhere else and make a different isomer? Okay, so we do the same. We take one off the end and we're allowed to put it only on a carbon which is in the middle. Okay, which means I can't put it there and I can't put it there. Well, I can't put it here either because it's already there. So obviously that isn't going to change the structure of the isomer that I already have. So therefore, my only answers for this are butane and 2-methyl propane. Right, let's move down to the next one. And that's a little bit more complicated, but again, it's not really very much more complicated. So this would be the examiner asking us for all the isomers of C5H12. And again, I think the logical one for any student would be to draw out the straight chained one to begin with, pentane of course, and then they would take one off the end. I always like to take the one on the right hand side, doesn't matter to be honest with you, and we put it on one that is no longer at the end. So if I go down to my 4 carbon chain here, if I put X and X, these are the 2 that are on the end, so that'll be that one and that one. So therefore I can put my carbon which is in the red box, I can put it either here or I can put it here. So if I put it where I have it here, I have got what we would call methyl butane. Okay, now some people might write 2-methyl butane there. Okay, I can also put it here, okay, on this carbon. Now let's draw that out. Okay, now some people will draw that out and then we'll go, okay, so there's 1, 2. We've also got 3-methyl butane. Now hopefully those of you who are on the ball can see why that would be a problem, because remember we always label from the side which gives the substituted or branched group or functional group the lowest possible number. So if I named from this side, this methyl group would actually be number 2, meaning that this compound here and this compound here are actually exactly the same compound. And here's the problem. If you give this as an answer to an examiner, you'll get a tick, you'll get it marked right. But if you then give this molecule here, which is the same molecule as 2-methyl butane up above, you will lose your good mark. Okay, you won't get any marks for this because it's wrong, but you will lose your good mark. It shows a complete lack of understanding as to what's going on in there. Okay, so be very careful. Check, use the rules that you've already been taught by your teacher. Okay, left an L out there. Use the rules you've already been taught by your teacher, okay, to make sure that you don't duplicate one of your answers. Right, let's see if we can finish there. Okay, so we'll take another one off the end and we'll put it on a carbon which remember is in the middle or is not on the end. So I can't put it here, that's on the end. I can't put it here, that's on an end. And I can't put it here, that's on the end. So I can only place that I have left to put it is on that carbon. So that brings us over to this compound here, which is called dimethyl propane is my longest carbon chain. Okay, so dimethyl, both there, and propane is my longest chain. dimethyl propane. I don't need to write 2 comma 2 hyphen, because if there's methyl groups on a propane, they can only be by default in position 2. I should have said earlier I don't need to write my 2 here for my 2 methyl butane, because as we discovered, if it's a butane and there's a methyl group on it, it can only be on position 2. So methyl butane would have been quite fine there. Okay, right. So I want you now, okay, to have a go at being able to do some of these. I'm going to flick onto the next page. Okay, sorry, 2 pages long. We'll come back to that. Functional group isomerism we're not bothered with. Okay, so I want you to name all the possible chain isomers of this compound C6H14. Now I'm going to do it, so you can probably pause the video now, okay, and then come back and check your answers. So we have straight chained hexane, so 6 carbons in a straight chain. We take 1 off the end and put it in the middle, so that brings us down to 5 carbons on the chain. Okay, we can't put it in one on the end, so we can put it there, and that gives us 2 methyl pentane. I'll just write very shorthand. Okay, now can I put it anywhere else? I can put it here. Okay, does that give me a different compound? Yes, it does. That gives me, this time, no matter what end I name it from, it gives me 3 methyl pentane. Can I put that carbon there? No, I can't, because if I do that and I number from that end, that gives me also 2 methyl pentane. Okay, so there's 3 we've got so far. Okay, let me just tidy this up. I'll do the 3 up here. So we've got 1, 2, 3, 4, 5, 6. Straight chain, 1, 2, 3, 4, 5. CH3 in number 2, 1, 2, 3, 4, 5. CH3 in number 3. So we've got hexane, 2 methyl pentane, 3 methyl pentane. Let's take 1 off the end of my pentanes and put it in the middle. Okay, so I can put it here. Okay, I can't put it there, I can't put it there, and I can't put it there. Those are all end carbons. So let's see what happens when I put it on the carbon with the dot. I'm down to 4 in my longest chain now. Okay, so I'm there. So that gives me, this time, 2 dimethyl propane this time. Okay, now could I put it anywhere else from up here? I could also put it there. I need to check, does that give me the same product that I had previously, the same isomer that I had previously, or different? Actually gives me a different one. So it gives me 2, so this is number 2, and this will be number 3, so it would give me 2, 3 hyphen dimethyl propane this time. Remember, you can only number from one end. You can't number this one number 2 and then go over here and number this one number 2. That's a big no-no. Okay, so that gives me, at the minute, I've got 5, right? And let's take my 4 carbon chain and see if there's anything that I can do with it. So if I take 1 off the end here, for example, can I put it here? No, because that's on the end, that's on the end, that's on the end, that's on the end, and I certainly can't put it here because that's already got 4 carbons on it, so there's no point, I can't, it's impossible to put it there. Okay, and therefore I have reached the end of my answer. So there's 5 possible answers there. Hopefully you can see where I'm getting them from. Right, let's look then at positional isomerism. So positional isomerism is actually very, very easy. Okay, so this, remember, is just changing the position of the functional group. So we're not messing around with side chains and alkyl groups this time, although sometimes you may be asked to do both chain isomerism and positional isomerism in one structure, but not here. Okay, so very simple. This one here is 1 bromo, and it's a propane. Okay, 1 because we're labeling from this side, so that's number 1. Prop because we've 3 carbons in the longest chain, and bromo, well, hopefully you can understand why it's bromo. Okay, then we go to here. We've just moved the bromine, the functional group, to 2 bromo propane. Yeah, can I move it to there? Well, hopefully you can see that if I moved it to there, it would not be 3-bromopropane. Okay, we would be numbering from the left to right this time, and we would be back to 1-bromopropane again. Okay, let's look at this one down here. This is C5H11OH, sorry. Okay, so this is pentanol. Okay, and I think most people, if they were asked to do this, would draw this structure here first. This is pentan 1 because the OH is on position number 1. I can move it to here, okay, and that will give me pentan no matter what number or what side I label from. That gives me pentan 3-all. Okay, now there is one of these missing. Can you maybe just pause the video, or you probably can even see it straight off. Okay, so if you can't, pause the video and have a think about it. Okay, yeah, of course I can put the OH on this one, or I could put the OH on this one, and that would give me pentan 2-all. So there's 3 possible isomers here. Without bringing in any chain isomerism in this context, there's 3 possible isomers of pentan 1-all, pentan 2-all, pentan 3-all. Okay, right. So let's have a look at a question on positional isomerism. Okay, so if we look at question 2 here, let me clear this. Okay, so we will do this one, and we will do this one. That one is the one I just did in actual fact, so we don't need to do that. So remember, we're just moving the functional group. So you can probably want to pause the video now, have a go at these, and then come back and I will do them. So C5H10, the tricky thing about this is you had to remember or work out that this was an alkene. So the functional group is a carbon-carbon double bond. Okay, so this is an unsaturated compound. We hadn't met any yet tonight, so I've just thrown it in to see who was on the ball. So this would be 1, 2, 3, 4, 5. We can have a double bond there. So that would be pent 1-ene. We can then move the double bond along. Very simple. And that will give me pent 2-ene. 2, 3, 4, 5. I can move the double bond along to here. Okay. Now does that give me now pent 3-ene? Have a look at it. Hopefully you were able to see that it doesn't, because in this case I would number from the right hand side to the left hand side, and in actual fact those 2 molecules are just exactly the same, except one of them is flipped 180 degrees. So this would actually be pent 2-ene, and again if you wrote this one and this one in your answer, you'll get a mark for that, and then you will lose your mark because you've duplicated and called the same molecule a different name. So you've shown a lack of understanding there. Okay, let's look at the last one. Very simple, I hope. Okay, so we have pent again, we have a bromo. So we have 1 bromo pentane. We can move that along to give me 2 bromo. I'll just write it shorthand. Pentane, I think you'll all have got my bromine on. We can move it along again. Okay, and that gives me, I can't, you sure, 3 bromo pentane. We can move it along again. Go to here. And does that give me 4 bromo pentane? Again, hopefully you're on the ball and you realize that that will not. In this instance, we would number from the right to the left, and that would give me position number 2. So that molecule and that molecule would be just 180 degrees, flipping of one, turn it into the other. So they're exactly the same molecule. And again, as you probably are worked out now, if you did give 4, you would lose your good mark that you got up here for working out 2 bromopentane. Okay guys, that's all I'm going to do on that in terms of structural isomerism. Okay, we've covered chain isomerism, we've covered positional isomerism. Like I said, you may get some questions which involve both. Alright, but I suggest you get the past paper question booklets and you have a go at them and expose yourself and experience those types of questions. Hope that helps.